Feeling like your Azure SQL database is stuck on speed when it really needs space. Most people confuse performance and scalability, but the truth is, performance is a prerequisite for scale. In this course, we are your non-techie guides, revealing the 5 keys to true mastery. First, master Azure storage, 2 worker speed and dock width like a warehouse manager. Second, learn the magic of scaling PaaS databases on the fly with compute sliders. Third, decode the secret alphabet soup of VM codes to perfectly match your database's constraint to its dedicated hardware vehicle. And finally, become a data engineering architect, re-architecting your data itself with partitioning, sharding, and compression to truly unconstrain the thin pipe. Uncompress your potential, master the configurations, and truly unlock Azure SQL's power. Start the course today and stop guessing. Have you ever clicked a button and stared at a frozen screen? That is poor performance. Think of performance as the speed limit of a single car. Scalability, on the other hand, is the width of the highway. It is about handling future traffic smoothly. In the cloud, we no longer plug in physical servers. We configure them. But beware, do not just throw money at a slow database. Identify the actual bottleneck, like CPU, memory, or storage, and adjust the right dials. Storage is the heart of any database, where physical read and write operations define performance. To master this in Azure, think like a warehouse manager. Storage capacity is the warehouse size. IOPs are the workers grabbing boxes, and throughput is the width of the loading dock door. In the cloud, these metrics are tied directly to the disk size you buy. Don't make the agonizing mistake of choosing a small P1 disk. It will be slow. Instead, purchase the larger P30, even if you don't need all the space. You are buying high performance, not just capacity. For peak efficiency, consolidate workloads and separate data and log files onto their own optimized disks. Forget the old way of building databases, unboxing permanent investments. Today, scaling your SQL is as easy as dragging a slider in Azure. Need more power for Black Friday? Increase your computing engine on the fly. Azure seamlessly switches to a larger environment with only a momentary hiccup, then deletes the old one when you're done. For managing hundreds of small databases, try an elastic pool. It's like a gym membership for your computing power. Giant databases use specialized subsystems for infinite capacity, and for intermittent workloads go serverless. It automatically scales up and even pauses to zero cost when not in use. This is modern cloud elasticity. If platform as a service is too restrictive, companies look to infrastructure as a service, or IaaS, to get full control over the Windows operating system. With Azure SQL Virtual Machines, you are essentially renting a raw server in Microsoft's data center and installing SQL Server yourself. Just like picking a vehicle, you must choose the right VM series. The Balance D is your standard pickup truck, while the M cargo van is memory optimized to hold vast amounts of cache. The E-Series is a high-speed bullet train designed with massive pipelines to communicate with storage faster than any other machine. When decoding the VM name, remember the S is an absolute requirement for fast premium storage, and the D is perfect for TempDB with zero latency. When buying bigger hardware isn't enough to solve your scaling problems, it's time to work smarter by changing how you structure your data. First, utilize table partitioning. This horizontally splits massive tables into invisible date-based boundaries, letting you instantly spotlight the current month while easily detaching old data. Next, apply data sharding to divide and conquer a crushing workload. By splitting data across multiple independent databases, you eliminate horizontal scaling limits. Finally, use data compression to maximize that thin pipe of storage bandwidth. By trading excess CPU power to unpack compressed data, you effectively overcome hardware bottlenecks. First, the course established the fundamental difference between performance and scalability. We learned how Azure abstracted storage and tied performance, measured in capacity, IOPS, and throughput, directly to provisioned disk size. We examined how managed instances simplified storage tuning, while business-critical tiers leveraged local SSDs. We then learned how to scale PaaS Azure SQL databases on the fly with compute sliders and how elastic pools shared resources through a gym membership model. We explored the unique split architectures of hyperscale and the auto-pausing functionality of serverless databases. For Azure SQL Virtual Machines, we decoded the alphabet soup of series and additive features to select dedicated high-bandwidth cores. Finally, we learned to re-architect the data itself using 3 data engineering techniques: table partitioning, data sharding, and data compression.